Hey everybody, this is Larry. This is day 23 of the what month is this? April Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm. For those of you celebrating, do you say happy Ramadan? I don't know. I feel like I'm always like messing up what to say, but uh, uh, anyway, yeah. Is it happy Ramadan? Ramadan Mubarak, hopefully, maybe? I don't know if I'm saying that right. Okay. Yeah, in any case, yeah, hope everyone's doing all right. But usually, actually, I'm not gonna lie, usually I actually do a fast on this time, but this year I'm my energy is just really down, and allergies is just kicking my butt, so I'm trying to maybe out eat it a little bit. I don't know if that's a real thing, but in any case, so we'll see what happens. As you kind of saw in yesterday's video, I was just especially on the premium one, I was sneezing like crazy. So hopefully this one will be a little bit better. Anyway, let's take a look at today's problem. 1416 returned the array, or restored the array. Ooh, excuse me. Drink some water. Alright, a program is supposed to print an array of integers. The program forgot to print white spaces, and the array is printed as a string of digits S, and all we know is that all integers in the array were in the range 1 to k, and there are no leading zeros in the array. Given the string S and the integer k, return the number of possible arrays that can be printed as S using the mentioned program. Since the answer is maybe very large, we turn it modulo some numbers. So first of all, remember the mod. Mod. Okay, let's see. What are we doing? What does K mean again? All integers array in. Okay. It just means that. Okay. Yeah, that means that the substring is less than K. Okay. I mean, this is a very standard E dynamic programming problem. The key thing to notice is, if you kind of drew the implicit graph, it is very tempting to just be like, okay, well, it's going to be n squared because, you're looking at sub-arrays. But of course, given that k is only up to 10 to the 9, that means that k will only take up at most 9 or 10 digits, I guess, right? And if it only takes 10 digits, then that means that for each index, for each prefix, you only care about 10 digits. So therefore, we should be okay. Okay. So then, with that said, then we could get started pretty quickly, right? So then we can just do something like count. We have index, and hopefully I don't have to explain this by now because we've had a week of dynamic programming. But index just shows you basically what it represents is the suffix of the string S, right? That is the suffix of that we're counting, right? So that means that another way of saying it is, given the suffix of S starting at index, what is the number of ways that satisfy this criteria of restored array or whatever, right? So, okay. And of course, index can go from 0 to n. Or to put n is equal to s. Yeah. So if index is equal to n, then we return 0. Maybe? Or maybe 1? Maybe 1 is fine. Yeah, 1 then. Right? Otherwise, then total is equal to 0. And then this is where we just use index, we do something one at a time, and you can kind of write this in a number of ways, but I'm gonna see how I'm gonna write it. So current is equal to s of index, int of this, right? And maybe what we want is say current index is equal to index, so maybe that's slightly better, right? Or maybe, yeah, okay, fine. Let's just rewrite this. Current is equal to 0, current index is 0, while current index is less than n, and current is less than k, or less than and equal to, I guess, right? Then current, we add it to int of s of current index. Of course, we increment current index, and of course, this should be a shift and add, right? So current we shift and then we add, and then here, now that we have this, then we want to count in current index. Current index is the last thing we consume, so we want the suffix of that, so it's +1, right? So then we have total, we add that to yeah, the number of count of this, yeah, right, maybe. Well, this is of course assuming that current is less than or equal to k, right, which is the constraint that we have for this problem. Otherwise we break. I mean, I think this gets checked anyway, but I don't know, just I just like to be thorough and then answer that mod, and of course as well, and this is not answer, it's total. Whoops. And then just return count of 0, and there we should be good, right? Maybe not. I don't. I want to see whether prefix zeros matter. Oh, there's no leading zeros. Okay, so that's why. Yeah. Okay. So if there are no leading zeros, that means that if s of index is equal to 0, well, I guess in this case technically is a character 0, then we return 0, right? What can it be? Why would this be out of bounds? What is this such that it is out of bounds? Because it can only be index can be O(n), right? What is going on here? Dong dong dong. It's actually surprising. Current index will be, oh, I see. Because I incremented by 1 here. So this is actually off. Yeah, okay. It's very awkward though. I think I'd like to write it this way instead to be more clear. Okay. And then of course you can add more things. Oh, I was going to hit submit. But yeah, of course the next thing to do is recognizing that you have to remember to memorize. So of course, index can go from 0 to n, and so we're just going to memorize it, right? And keeping in mind that, as we said, okay, we'll do the analysis afterwards, actually. Hang on. Okay, yeah. So basically the analysis is that, okay, what is the total time complexity, right? Total time complexity is, of course, equal to time per input times number of input, right? Or total number of input. So here, the total number of inputs, number of inputs is equal to O of n, and each input takes O of log k, right? For upper bound of k, or maybe max k or something like this. And of course technically this is a log base 10, but of course big O takes it away because log base 10 is just over divided by log 10, which big O takes away anyway. So that means that total time is going to be O of n log k, which means it's going to be 10 to the 5th times 10 or something like this in any practical. So that's going to be fast enough. I say that and hopefully it's true. Well, I did forget to do one thing, so that would have been really kind of sad. But okay, now we can maybe, hopefully this works. Yeah. What did I get wrong last time? I did it. It's just the only contest, I guess. So, oh, I didn't do the leading 0, huh? Which is fine, but then I don't know why I don't know. Maybe there's some weird leading 0 things. But yeah, that's all I have for this one. Let me know what you think. And yeah, this is kind of brute force. I don't know that I explained this one very well, to be honest. Let me try a little bit. But basically, the idea is that, okay, so let's say you have, I think I just kind of skipped ahead. But let's say you have some string, right? And you have some k is equal to, I don't know, some other string. And basically, all the brute force way is just, okay, let's see one digit, okay? is this one digit. Let's say we take this one digit, that means that we do a recursion on the suffix, and then now we take 2 digits, and then now we do a recursion on that suffix, and then we do 3 digits, and then so forth, and then now until this number is bigger than k, and then you go, okay, well, this is no bueno, so let's break, because everything to the right of that is going to be bigger, and then we just kind of sum up the number of counts, and that's pretty much the way that I did it. Yeah. Okay, now I think that's all I have for today. The contest is in like 2 hours or something, so if you're doing that, good luck. And yeah, that's all I have. Hope y'all have a great rest of the weekend, and to whatever y'all are celebrating. That's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later, and take care. Bye bye.